So, welcome everybody. Alright, we're making our way through chapter 2. Today we're doing the derivatives of exponentials. And what you're going to start to see is that we're going to be really consolidating everything we've learned together and using all of the rules that we've learned so far today. Okay? So, we're going to start with just E, and 98% of what we do in Year 12 will just be based off E, and then a little bit later in the lesson we'll look at differentiating other exponentials, but we are just starting with E. So these are the rules. If we have e to the x, the derivative is e to the x. Okay, that's the meme on the front, that explains that. It doesn't change. Okay? However, if we have e to the f of x, it's some function that's the power, then the derivative is f dash of x. So that's the derivative of the power, and then e to the fx just remains the same. See, it stays the same. And then I've got a third one, okay, which is a direct application of this, just because we deal with it a fair bit. If we have e to the kx, okay, that can be any number, all right? Even if it's just minus 1, then the derivative is ke to the kx. Okay, so that's going to be popping up. So let's leap straight into this one here. I've got this 3 hanging out the front, and I'm just going to leave it there when I do my derivative, okay, because it's just a product, and then I'm differentiating what's left over, e to the 2x plus 5. Okay, it's not e to the x, it is a function. It's e to the power of some function, where the function is 2x plus 5. So what we have at the front there is the derivative of 2x plus 5. That's going to be 2. And then, so we've got f dash of x, and then e to the f of x. E to the 2x plus 5. Okay, and 3 times 2 gives us the 6. You can jump straight there after you start to see these bits. Okay. On B, we have x squared times e to the x. What rule do we use when we want to find the derivative of two things that are multiplying? The product rule. Very, very good. Okay, so when we first looked at the product rule, you guys had brackets, all right, and it was very clear. This is one function, this is another. Now, they're not going to be that generous, particularly when we have e and ln and some of the trig ratios a bit later on. We have to look at that and recognize that is u times v. I have to use the product rule. These are going to pop up today. So we just have to keep an eye out for it. We've got u is x squared and v is e to the x. U dash will be 2x. And v dash will just be e to the x, right? E to the x, derivative, e to the x. Let's put all that together. U dash v plus uv dash. So product rule has the plus, quotient rule has the minus. All right, and now, another way we could express this is by factorising it. If I'm looking along here and I'm going, what's common to both of these terms is x and e to the x. We could factorise that and we'd be left with 2 plus x. If you expand this, it gives you what we have above. So that can be one way we can express it. Okay, let's move on to C. Here we have one function divided by another function. What rule do we use when we have one function divided by another? Quotient. Quotient rule, very, very good. So u is going to be 3x to the 4, take e to the x to the half. All right, e to the x to the half because it's the square root of x. Square root means x to the half. V is going to be x take 3e to the x to the power of half. Right. These what we have at the bottom, expressed it with the power of n. Okay, u dash. This part is going to 12x to the 3. All right, 3 times 4 gives us 12, and then that power changes from 4 to 3. Now we're going to have to watch this next one carefully. I'll put the negative down first, and we can see we have e to the x to the half. Okay, so it's not e to the x, so that means we're not using this rule. We have to use this one because it's e to some function where the function is x to the half. So that means the first thing I need is the derivative of the power. If I have x to the half, what's the derivative of x to the half? Half x to the minus half. Okay? And then we just have e to the f of x. This part stays the same. I'm going to explain that part again, because that's the part we can get tripped up on, I think. So let's look up here. E to the f of x. Alright? So then the derivative, f dash of x, that's the derivative of x to the half. And then this part stays the same, e to the f of x. Okay. Let's go to b dash. In order to differentiate this, we can see we have a function to the power of n. When we have a function to the power of n, we're going to use the chain rule. Alright? That's going n f of x to the n take 1. N f of x, n take 1, times by f dash of x, the derivative of the inside. 3e to the x just stays as 3e to the x. We will combine all of that together. This is going to give us f dash of x. Again, being consistent with our terminology. U dash v. I should have brackets there. U dash v. Take away u v dash. That's the quotient rule. U dash v, take away u v dash, all on top of v squared. So what is v? This is v, so when we square it, we annihilate the square root. Gone. So we can get rid of that. Square root squared. Okay, u dash v, take u v dash on v squared. So we can see we're combining all of those things together, aren't we? Alright, now just a little tip before we run off. We are going to be confronted with time and time again things like this, x on 2, okay, or x on 4. Now, when we're doing calculus, we should think about this as half times x. Okay, that's the best way to think about that. Alright, let's get stuck into 2f.